Hi there, this is Srikanth Dasari. So in this lesson, we are going to learn how to program a stack data structure, which is a linear data structure. Okay. So already we have done two videos in this data structure series. So if you go to playlists in my channel. Okay. So first of all, this is Dasari Tuts, my video tutorial channel in YouTube. So if you go to playlist section in that, you find a playlist for data structures. Okay. So there are two videos already I have done. First one using building a stacked linear data structure using a plain array. The second one is a queue data structure. So how to code a queue data structure in C using a plain array. And the third one now right now I'm going to do, which will be listed here as soon as I finish this video tutorial, which is going to be programming a data structure, stack data structure using a structure. Okay, so here in this tutorial what you are going to do is so we would embed the both the array and the top excuse me, into a single structure, and then we would build a linear and perform all the operations on the stack using that stack structure here. Okay, so let me launch the IDE. So we know that we are using a VC++ 2005 expression for programming purpose. Okay, so here I have created a project under the name stack struct here, which consists nothing but stack.c file. Okay, so here I am adding all the basic stuff like header files first. Okay, so we are doing the programming from the very scratch, since we are introducing ourselves to data structures, programming data structures concept here. Okay, so I'm just writing all the header files and main and all the basic stuff like this. Okay, so it returns, and you can see it. Okay, so here we have all the basic stuff. Nothing happens if you run the program. Nothing exciting happens. It just displays the console window. Okay, so before diving into application or for programming the stack, let's write a few lines about stack. Okay, stack is a linear data structure. Stack is a linear data structure which follow the principle of last in first out. Okay, which in short form is also known as LIFO. Okay, so to do that, so to perform all the operations first, we need to build a menu. Okay, so for that, let's take a variable here. Okay, so before taking the structure or array of a stack in particular, we need to build some menu to perform certain operations on the stack here. Okay, so first for that purpose, I am taking a variable choice here. Okay, so scan the choice. Okay, so let's put it in do while loop, since it need to repeat all the time. While choice not equal to 4, that would be the case here. Okay, so inside the do while loop we have switch case. Okay, or else first we need to have all the list of operations here. So /t, uh, let's say 1 for push an element. Okay, let's be more clear here. Push an element into stack. Okay, so push an element into stack, and 2 would be pop an element an element from stack. So all these messages are just for understanding purpose here. Okay, so we need not write this many big and huge messages when you are developing a choice switch case choice for your program. So in third operation would be the contents display the contents or elements display the elements of the stack display the elements of the stack. Okay, and the fourth one is nothing very simple. To exit the program, exit, okay, from the program. Okay, So here we have all the basic choices, choice menu of we are building a menu here. So I'm just taking the choice as input. Okay, so switch choice. So now we need to have our switch case. Okay, so switch. What happens here is switch choice. Okay, so switch choice, and here case one. I'm just putting the cases also where we need to add develop a module or add the code regarding the what we call the push operation here. So case 2 has the code regarding code or the module or a function regarding the popping element pop operation here. Okay, so case 3 consists of code or module regarding the displaying your stack's contents, and case 4 is nothing but an exit function here. Okay, so exit of 0 or whatever you wanted with an argument and followed by a break. Okay, so followed by the break here. Right, excuse me, so I have forgot. Rest of thing would be default. Okay, so default you can have a message here, printf /t wrong entry, wrong entry, try again. Like you can say something like this. You can have some so try again and have some message, some sort of message here like this. Okay, so let's put a break for default also. Default also. So it will come out of that immediately and go loop back once again. Okay, so here we have all the menu built up for our the case sorry stack program here. If you run until now, everything goes well. You just have the menu displayed in the output window here. Okay, so here if I take any of thing, okay, so anything like 1 or 2, it just takes out, nothing happens here because we haven't put any code here, so it just keeps on repeating. If you take 4, it comes out of program since we have put the exit function here. Okay, so here there is we need to have one more thing here. Enter the choice /string, enter your enter your choice from 1 to 4. Okay, some sort of message which is very convincing for the user, so what's going on in the program so that he can do the certain operation. Okay, so here again I'm running the program. So enter your choice 1 to 4. It's what the message get displayed, very neat and presentable output here. So if you press anything other than this operations here, if you don't press 1 2 3 or 4, if you press any other if you give any other input, it should say wrong entry. Okay, so wrong entry, try again, and it just clears everything and gives you the menu and the first hand menu. Okay, so let's do one thing here. So what shall we do is let's clear the screen by putting system CLS here. Okay, so system CLS, it's very specific to so what we call okay, so that wrong entry is not getting displayed here. Okay, we have cleared it. So also we need to have that message also, the wrong entry, since we have so since it enters into default thing. Okay, so default thing, or else you can have wrong entry, and then you can have system CLS here, or else. So we are testing the menu once again. So 1, okay, nothing happens. Nothing happens here. 2, nothing happens. 3, nothing happens. 4, nothing happens. 4, it gets out of the program. So 5, it says wrong entry, and then it clears the screen. Wrong entry, clears the screen, and then it comes out of the loop here. Okay, so to be more specific, you can have here. So after that, you can have a system CLS here. Okay, so it's just displaying the message and clearing everything. Else you can put it. Okay, so here we are, wrong entry, try again. Okay, so everything is perfect, our menu right now. Okay, so now what we need to do is, so we need to build a structure for our stack. Okay, so we need to build a structure for our stack. So that's our motto here. So since we are demonstrating or building a stack linear data structure using a structure here. Okay, so let me take a structure first of all. After that, let's build up the functions here. Okay, so I'm naming the name of the structure as stack here. Okay, okay. So in this structure, I am taking the array which we are going to use. Okay, so which we are going to use for our stack array. Okay, so let's take it as a stack array, or let's say ARR. Okay, STK or whatever you want. You can keep it as TK ARR. Okay, of max. Let's define a macro also. So it's as we have done it in. Okay, so to keep it simple, let's keep it a ARR here. So top is another very essential variable when you are developing code using a data structure stack. You need the top is more essential. Okay, so every time you need to know what is the topmost element of the stack using the top variable only. So here I am defining a macro. So for the purpose of defining the size of the stack, to make it simple, I'm just keeping it as 5. Okay, so okay, so we need not develop a lengthy stack. So later in the program, if you want more number of elements in the stack, you can directly change it here such that it affects the entire program. Okay, so also I'm defining a variable for my structure st at the very beginning. Okay, so now what I'm doing is, so using this st variable, so I'm just initializing my top to -1, which is very essential, which says that uh, top is, sorry, stack is empty. Okay, so this gives an illusion that stack is empty at the very beginning, since it does not have any elements. So whenever you're developing your functions for your program, you need to have that you need to have you need to check whether the stack is empty or full, and so on and so forth here. Okay, so first let us write a function for push operation here. Okay, so the very first operation in the stack is push operation. So here what I'm doing is I'm just grabbing the input from the user. Let's say a int item. Okay, so before pushing an element into stack, the first you need to check whether the stack is full or not. So if that condition goes like this, if top is equal to max minus, so max minus 1, so max minus 1, so then you say that the stack is full here. Okay, so then you can have a message printf /t, the stack is full. Okay, so here you have a nice message, the printf /t, the stack is full. So else condition comes our real coding here of how to push an element. Okay, so so if the stack is full, it leads to an overflow condition here. Okay, so in this case, rather than saying stack is full, you can say directly the stack is overflow. Okay, so you can say directly like this. Okay, so this means that the stack is overflow. That means the stack is full already. So if you are trying to perform this push operation on the stack which is full, then it leads to a condition known as overflow. Okay, so before you are developing a push operation or writing code for push operation, you need to check whether the stack is full or not. Okay, so there is no case in point. So you adding an element in the stack where there is no room to add more elements here. Okay, so now coming to the else condition here. So what we have is, the first and foremost thing before pushing an element into stack, so first you need to increment the stack position here. Okay, the top of the stack's position, you need to increment that. Excuse me. So for that reason, I have used this statement here. So st.top plus plus, which means that it increments the topmost position to one level ahead, and then you need to push the item in your array. Okay, so here our array is, name of the array is here. So st error of top is equal to item. Okay, so item. So what is the item? So first we need to scan the item here. That too we do it in else condition. Let's say filter /t. So enter the element to be pushed. Enter the element to be pushed into the stack. Okay. So we are just scanning the element which we are going to be pushed into the stack using a scanf. Okay. So ampersand item. Okay. So I've done a silly mistake here. Percentage T item here. Okay. So I'm just scanning the element, whatever I'm going to put it into the stack at the appropriate position of the top here. Okay, so done with our coding with our push operation here. So what we need to do is I'm just adding the prototype, which is very essential at the beginning. So since we are define the function the later the main, so after the main function. Okay, so here I'm calling the push function directly in the case one. So since we are done with the coding of push operation, so I'm directly calling the push function here. Okay, so calling the push function. So when I'm running the program, since we have an error, top is not declared. It says okay, choice. Let's put it our declarations at the very beginning, since it does not follow the ANSI standards. System there is a problem with top here somewhere. Top, okay, since we have embedded it in our structure here, we need to be more specific. Oh my goodness, so wherever you need to use this top, you need to be more specific here. Okay, so st.top, the structure element. Okay, so here I am taking the first operation, which is a push an element into stack, pop up push operation. Okay, so as soon as so I enter one, it should call like it should automatically jump there, so it's not taking. Interestingly, so we had a void push definition here. So what is happening in our case one? Okay, scan of choice. So as soon as you enter into that, call the push function. So here we are in the void push here. Should enter the else condition. If tested on top is not max minus one, it should enter into the. It's not happening here. Unfortunately, stack is overflow. How come stack is overflow? Interestingly, how come stack is overflow? Interesting. Interestingly, top is equal to max minus 1. We have already initialized top as is equal to minus 1. So let's do one thing. Let's initialize this 2 in globally. Maybe that's the problem here, since we are doing it in main. Since we are doing it in main function, should not say top is equal to max stack overflow. Yeah, so here we are in the error here. So I have just used a single is equal to, which is a stupid silly mistake. So if you make it so double equal to, so run your program. Okay, so it gives you a menu of running. So here we are with all the good menu here. So if you select the first operation, it asks you to enter an element to push into a stack. So if you say 1, dollar takes the element, and if you take the first choice once again, and if you keep on entering the elements, so if you keep on entering 5 elements like this, so after you enter the fifth element, so if you try to enter the one more element, so it says so there is, since there is no room for adding a new element in the stack, so automatically this message gets displayed here. Okay, stack is overflow. Okay, so in the same way, so since we have done with our push operation, so let's do it. So let's do the pop operation also. So let's say void pop. So, okay, so according to the algorithm, so first you need to check whether the stack is empty. There is no case in point of popping an element from an empty stack, so which leads to the underflow condition. So we need to put that checking first here. Okay, so if you say something like this, st.top, so double is equal to -1. So that, and this leads to a situation that the stack is underflow. Okay, so then you can have a message here, something like this. So printf /n/t stack underflow, or else you can say simply like stack underflow. So underflow means that when you are doing so what we call pop operation on in an empty stack, so that leads you to the underflow condition. So when it's not underflow error, so you can have in the else condition, what you can do is, so first you need to have an item. So let's say int item. So I have taken a variable. That's what I'm saying, is it saying it as item here. So item is equal to st dot arr of top. Okay. So this means that the topmost element of the stack is popped out from the array, and we are placing it in the item variable. And then what we are doing is, and then we are decrementing the top variable here. Okay. So and then we are decrementing the top variable. So this leads to pop operation, perfection of the pop operation. Okay. So if you want, you can have a message also. The deleted item, the popped out element, you can have a printf statement saying like this: printf/t. The popped element, the popped element is percentage t. So item. Okay. So since we have put it in an item, so directly you can say something like this. Okay. So if you want for more clarity, you can have a system.cls function which is equivalent to clrscr. Okay. So run your. Oops, we have an error. So what is the error here? Top. Okay, my goodness. Again, I'm using a top directly. So since we have put the top in a structured variable, so we need to have. Okay, so we need to call our pop operation. So just defining a function will not work here. So we need to call our pop operation. Again, we have an error. Redefinition of pop. Okay, since we didn't have a prototype, so it's showing us as an error. So let's have a prototype for our function at the very beginning. Ready? Right? So nothing but okay. So now you ran your program successfully. So if you select the first operation, so let's put all the elements in the stack. Okay. So I'm just putting all the elements in the stack. Okay. So now if you take the second operation, so it popped element is 5 here. Okay. So since the topmost element, so if you add 1, 2, 3, 4, and 5, the topmost element would be 5. Okay. Since we are adding from the top, so that's the topmost element will be popped out from the stack and it's displayed here. Okay. So the pop element is 5. Okay. So for the very next time you take the second operation once again, the popped out element will be the very next element, the very next topmost element after the 5, which is 4. Here. Okay. So if you take it once again, it shows you. Sorry, I have taken third operation. So again, if you do the pop operation, so the pop element will be 3. So again, if you do the pop operation, the pop element will be 2. So again, if you do the pop operation, the pop element. Okay, sorry, by mistakenly I have taken 4 there to exit here. Okay, so let's do our display also. The last function, say disp. Okay, so let's say it as disp to keep it simple. So display. So before displaying also, you need to check according to algorithm. You need to check something like this: if st dot top, st dot top is equal to is equal to -1, we can say something like this. We can have a message printer /n/t, the stack is empty. Okay, so here you should use the word empty because you don't have any contents in your stack to display. So that's the reason you are saying it as a stack is empty. Okay, so in the else condition, you need to have an variable. So for I is equal to top. Okay, so st dot top, from topmost, you need to display your contents from topmost element. Okay, so st dot top. Okay, so I less than, so I is equal to st dot top, so I greater than or equal to 0, I greater than or equal to 0, and I minus minus. Okay, so this is the case we need to use I minus minus. So with this condition, I greater than or equal to 0, so with this condition I need to display the elements of the stack using the, so let's put in a printf statement here, percentage %t slash t. Okay, so st dot arr of I. Okay, sorry, so I've just put it in this way. So st dot top, I greater than equal to 0, I minus minus. So we are just displaying. Okay, let's have a prototype also for our display function at the very beginning, since we are defining the methods after the main function here. Okay, so let me call the display function here. So display. Okay, so let's run the program. We have an error yet again. So we have taken directly, we haven't taken directly the I variable, we haven't defined I variable here. Okay, so let's say something like this, int I, and prior to that let's have our system CLS also. Okay, so in the program, so if you take a display for the very first time, it says stack is empty. Okay, since we haven't put any elements in the stack, the first message is tell us the first condition. If you go to the program, go back to the program, so in the display function here, come out of the full screen and take the output also simultaneously. Okay, so the stack is empty because it checks the first condition here, which is if I is equal to, it's top is equal to -1, the stack is empty. Okay, so that's the reason you're reading stack is empty here. Okay, so if you go to full screen, so if you select what we call first operation, so let's put some elements in the stack here, 3, 4, 5. Okay, so now if you select the display, so you have all your elements displayed here. Okay, so 5, 4, 3, 2, 1 here. Okay, so let's make it more beautiful. So let's say, so what we call let's have a message, the printf message here, printf /n/t, the contents of the stack, the contents of the stack are, so all these messages are just for better understanding purpose. Okay, or else you can have okay, so now again, if you have 3, the stack is empty. So again, if you select the first operation and if you keep on adding the elements, let's add all the elements here. So 5 elements. Now if you take the third operation, the contents of the stack are 5, 4, 3, 2, and 1. It's playing in the same line. Let's put it in the last line here. Sorry, next line. So to do that, let's, if we have a simple /n here, it makes us the work done. Okay, so let's run the program once again. So let's enter all the elements in our stack, 3 and 4 and 5. Let's put the display, so contents of the stack. Okay, so we have 5, 4, 3, 2, 1 as the our contents of the stack here. Okay, so if you want a pop element, the pop element is 5, and now if you have a display, you just have 4, 3, 2, 1 as the contents of your stack. So again, if you perform the pop operation, so you have popped out the fourth element, and now if you take the display operation, so you get 3, 2, 1. Okay, so again, if you do the pop operation, you keep on popping the elements. So at one stage, so you have only popped element, one is also popped, and now the stack should be empty. Okay, so this is the way you code your stack data structure. Stack data structure using structure, using a structure stack here. Okay, so if you want to revise once again, so what you have done, so here we have taken a structure. Okay, So let's put a comment. Let me put a comment here. Structure to hold our stack variables. Structure to hold our stack variables. Okay. So array, the actual stack array. So the actual stack array. So actual stack array. On the top, the variable to hold to know the topmost element. Okay. Topmost top variable. Okay. Top to know the topmost element. To topmost element. Top to know the topmost element, or to know the topmost, or to know the position of the top of the stack, or to know the top to know the position of the top of the stack. Okay. So here we have all the prototypes of function prototypes. Since we have taken 3 different functions, one for push operation, pop operation, and display. So I'm just commenting it also function prototypes. So for all the functions here, okay. So function push operation to perform push function to perform the push operation, pop to perform the pop operation, display to display. Okay. So main here initializing the topmost element, top to -1. Initializing the top is equal to -1. Top to -1. At the very beginning, to show that the stack is empty. Okay. So the very first thing you do whenever you start coding a stack data structure, linear data structure, is first you need to initialize the top variable to -1, such that you can show that the stack initially the content of the stack are empty. Okay, so there is no case in point that you can know that since the array index starts from 0. So if you don't use this kind of mechanism, you will fall into a trap or a loophole or error. Okay, so this is the menu of our program. Okay. So menu lists the various operations. So menu lists the various operations. So various operations in the stack. Okay. So here we have all the case functions. The push function here, the definition of push function goes here. The definition of the push function. The definition of the push function to perform. So definition of the push function to perform the push operation. Okay. Push operation. Okay. Here we are the actual adding element to the stack is going on here. Okay. So adding an element into the stack. So adding the element into the stack from top. Okay. So here the actual removing element, the operation of removing the element. Remove the element from the stack from the very top. Okay. So this is a pop operation. So okay, I can have also another comment here. The definition. So definition. So the pop function, pop operation, pop function, which is used. Okay, the definition of the pop operation, which is used to remove an element from the stack. The definition to perform the push operation, to perform to remove an element, from the stack. Okay. So here we have our mighty display function. The definition of a display function. Or else directly let's write a display function. Display function to see the contents of the stack. Okay. So display function to see the contents of the stack, which is very essential here. Okay. So here we have a pop operation to perform the pop operation, and we have a push function to perform the push operation. So also we have uh, the menu here in the main function here. Okay, so this is the basic stuff about so how to code a stack linear data structure which follows the principle of LIFO, using structure enclosing the variables of the stack to hold our stack variables inside a structure here. Okay, to summarize one last time once again, so we have taken a stack structure which holds nothing but an array to hold the stack elements on the top variable to hold to know the topmost portion of the stack, and then we have defined three different functions: push, pop, and display. So push operation just pushes the element in the stack here. Okay, so here we have so before pushing an element into stack, we need to check first whether the stack is full or not. Okay, so there is no case in point of us if we are the stack is full, then we can't enter or store elements in the stack. So first we need to check this condition, and if it's not true, then you can using the else statement you can add the element in the topmost position of the stack. Okay, so in the same way when you are performing your pop operation, whether you need to check whether the stack is underflow, which means that if the stack is empty, so there is you can't remove the elements from the empty stack, which leads to an underflow error. So that's the reason you need to check first whether the stack is empty or not, and then if it's not true, um, then you're using the else condition, you can remove the topmost element from the stack, and then you can decrement the position of the top to one less. Okay, okay. So we have the last but not the least display function to display the contents of the stack. If you run the program all together once again, so you have the menu. Okay, so you have the menu, and you can directly add an element into the stack like using our first operation. So I have just adding all the elements, five elements here. Okay, so here we have the five elements for the stack: 5, 4, 3, 2, 1. If you want, you can pop the elements. The pop element is 5. If you want, again use the display function. So again, using the display, you can display the remaining elements of the stack, which are 4, 3, 2, and 1. So finally, if you press 4, you come out of the program into our coding section here. Okay, so this is the basic stuff. So see you in the next lesson. Goodbye.